tiled VAE encoder and decoder is going to be one of the important nodes used in this video. Keep watching if you want to learn more. How can you upscale images with 4 GB of VRAM? This is a common problem for most ComfyUI users. I made this video to share a couple of effective methods to upscale your images in ComfyUI without running out of VRAM. Although there are many ways to upscale in ComfyUI, most require more than 4 GB of VRAM. However, there are a few methods you can use to perform upscaling and achieve good results with low VRAM graphics cards. I will cover each method, show you the best settings for them, and explain their use cases. So make sure to watch till the end. Let's get started. The first method involves running the generated image through a second K sampler with low denoise. This can produce impressive results, especially when paired with an image sharpening node. As you can see from these comparisons, you barely lose any details with this upscale method. The images generally look quite similar and often gain a bit more detail, while also correcting some flaws from the initial generation. Plus, it's pretty fast too. I have posted 2 workflows in the description that cover both upscale methods discussed in this video. One is for regular text-to-image and image-to-image generation, while the other is similar but includes ControlNet. You can find all the custom node extension links or names in the description as well. Just head on over to ComfyUI Manager and install them one by one. The first method involves generating an image normally, then upscaling it using the normal image upscale node in ComfyUI, and finally running it through a second K sampler. I have demonstrated how to build this workflow from scratch in my previous video on how to install ComfyUI. You can find the link in the description. I will show you how it works now. This is the workflow I posted in the description. In this first section, I generate an image regularly. I'm using a node called Seed Everywhere. This node allows us to use the same seed anywhere we want in the workflow, so you don't have to manually set the seed one by one. I'm also using a switch here, where we can toggle between text to image and image to image. 1 is for text to image, and 2 is for image to image. You can load your image from this first image loader. Make sure to change the denoise to 1 on this first K sampler when you are doing text to image. Once the image is generated, I send it to the next section. I'm using a regular image upscale node with the method set to Lanczos. It is advised not to go beyond 2 times on the upscale here. Then I run it through a VAE encoder. After encoding it to latent, I run it through a new K sampler. I'm using the same seed, same number of steps, same CFG value, and same sampler here. Make sure to use a low denoise value between 1 and 3 to keep the details intact. I'm using a tiled VAE decoder here. This is very important because since the output is upscaled, it might fail to decode with a regular decode node. So make sure to use a tiled decoder here. Before I save the upscaled image, I run it through an image sharpen node with the alpha set to a very low value. I have set up a codeformer Facerestore node here, but it can sometimes mess up faces, especially with unrealistic images. You can disable it if you don't want to use it. Alternatively, you can use an advanced K sampler instead of the regular one to make things faster by only generating the last 5 steps instead of running all the steps. I'm using the same number of steps, same CFG, and same scheduler here, but I have set the starting step to 25 and the end step to 30. That is the last 5 steps of the first generation. This will significantly save a lot of time and give you the same result. As you can see, here is the side-by-side comparison between running the full 30 steps and the last 5 steps. They look identical. Also, here is the side-by-side comparison between the first image and the upscaled image with and without sharpening. It's a really solid way to upscale an image using low VRAM graphic cards. The next upscale method you can use in low VRAM setups is called UltimateSDUpscaler. This is a tile-based image upscaler and requires some fine-tuning to get good results. I say that because it can lead to images that look like this if you don't set it up properly. Since we have our first generation here, I'm going to disable the other groups and then go to UltimateSDUpscale and enable that group. Even though it has a built-in tiled VAE decoder, it runs out of VRAM. So we are using the regular image upscale node to upscale our first generated image. I'm using Lanczos as the upscale method. It is advised not to go beyond 2 times on the scale here. I'm using the same seed, same number of steps, same CFG value, and same sampler here. I have set the upscale multiplier to 1 and the denoise to something low, between 0.1 and 0.3. You can leave the rest of the settings as they are. I'm running the upscaled image through an image sharpen node with a very low alpha value as well. You can disable the codeformer Facerestore parts I have included here if you want. This is a side-by-side comparison between the base generation and the upscaled image, with and without sharpening. As you can see, the upscaled image looks better and does not lose much detail from the original generation. The only downside to UltimateSDUpscaler is that it takes longer than the previous method we tried. Those are the best upscale methods I found that work for low VRAM AMD graphic cards. I have also included all the model names I used in this workflow in the video description. You can go to the model manager in ComfyUI and install them one by one. I have also included a face detailer section next to each upscaler group. Stay tuned, and I will tell you more about fixing and swapping faces in the next video.
Alright guys, make sure to help me out by liking the video and subscribing to my channel if you want to see more awesome videos like this. Thanks a lot.